CFV engages interfaith conversations on campus, which include discussions from various worldviews, whether that's a worldview that comes from a religious system or a secular scientific system or a spiritual place. We think engaging these ideas together is important. So for us to put this in conversation with questions is really a wonderful opportunity for dialogue. The theme for Artsfest this year is time, and this program relates to time in several poignant ways. We're going to be asking 3 core questions tonight. What is the nature of time? How do we understand the beginning and the end of the cosmos and creation? And what are the implications for our own place in the universe and our meaning making as we begin to further understand and manipulate time? Science and theology must respond to time, and both have made considerable efforts to describe time, react to time's consequences, and articulate that which is not yet understood about time. So we're going to be led through this discussion by 2 brilliant minds. Professor James McGrath is the Clarence L. Goodwin Chair in New Testament Language and Literature at Butler University. In addition to his works in biblical studies, Dr. McGrath also writes and speaks about the intersection of religion and theology on the one hand, and science, fact, and science fiction on the other. He is the editor of Religion and Science Fiction and the co-editor of Time and Relative Dimensions in Faith, Religion, and Doctor Who. Professor Brian Murphy served as chair of the Department of Physics and Astronomy for nearly 8 years and has also served as the director of this wonderful building, the Holcomb Observatory and Planetarium, for all of his 23 years here at Butler. In his role as director of the observatory, he has given nearly 500 television and radio interviews on the subjects of physics and astronomy, including such notables as the BBC, National Geographic, and NPR. So after the conversation that we're about to enjoy and have together with these 2 scholars, Professor McGrath and Professor Murphy will lead us through several stages of this discussion, and then we'll have the opportunity to get a tour of the building and see the telescope upstairs, and there will be a very brief planetarium show at the very end. And then as you're walking out, if you saw the telescope outside as you came in, that is going to be redirected and we'll be able to see Jupiter as you walk out. So we do encourage you, as you leave the event, to take just a few seconds to poke your head in and see Jupiter. So throughout it all, our main goal is that we'll engage the questions of time and cosmos. We'll probably not figure it all out, but we hope to develop a greater appreciation for that which we investigate, that which we take on faith, and that which is unknown altogether. Thank you so much, and without further ado...
Daniel, I have to ask as the first question, how much time do we have?
How much time can they bear with us?
45 minutes.
We should be constrained by time, not just talk about time. We lose track of time.
Want me to start real quick?
Yeah, absolutely.
Since I'm sort of the boss of the building here, only inside the perimeter though. How many noticed what you came through on the way in? Just outside. Not outside the building, right outside this wall here. Good, a bunch of clocks. And it's actually something that's stuck in time. If you look at the figures there, you will notice they are 1954 characters. I don't think we see rickshaws in Tokyo anymore. Anyway, just to let you know that. So, in another thing, how many of you saw the moon before you came in? You saw it as it was 1.3 seconds ago. When you see Jupiter, you can see it as 25 minutes ago. All right? So keep all that in mind in our discussion today, because it's going to lead to this in one of the questions. And I'll let you go here.
Okay. Yeah. And hopefully, as the person who's here to talk mostly about religion, right? Not simply from a religious perspective per se, or one religious perspective, but about religion, about theology, about philosophy of religion, those kinds of things. Maybe the thing that I should say is that one might assume that I'm going to be the voice from the past, right? But there's a lot of interesting religious interaction with questions about physics, and there's a lot of interesting conversations taking place. And there's a lot of interesting ways that physicists are prone to throw mentions of God into the things they write. And so hopefully we'll have a and interesting conversation. Philosophers of religion have been wondering about time and talking about how God relates to time for a long time. And so maybe the thing to do is to ask a physicist, and maybe a physicist can set us straight on some of these things, right? There's a long-standing view of God as outside of time, right? So that essentially time comes into existence when God creates, and it's just an aspect of the created order, right? With God being thought of as timeless. And for a lot of theologians that has made sense, right? It depicts God as absolute, unchanging, perfect, immutable. Does it make any sense in physics?
Well, if I was sitting in a bar with a beer, in which physicists tend to do,
That can be right.
usually sometime around this time of night, we would say, well, could time just, God be so-called be ageless? Well, if God traveled at the speed of light, yes. So I'm bringing up my physics point of views, and that actually gets into something we call special relativity. Special relativity basically deals with things such as moving near the speed of light. The faster you go, what happens? Time slows down for you relative to everything else around you. So he's saying, I got a new science fiction plot here going. Yeah, so that's one of the things about, that would be my first thing. I'm taking it from the sort of the agnostic physics point of view here, okay? But one of the things, the nature of time literally is relative, all right? And that's something they realized around the early 1900s, late 1800s. And part of it had to do with the fact that they figured out that the speed of light was a constant no matter how you viewed something. If I'm coming at you at half the speed of light and send a laser beam at you, you still measure that at coming at you as the speed of light, not 1.5 times the speed of light. And if that is true, just by a very simple geometric diagram, very simple. In fact, I think, Eris, I saw you over there somewhere. I showed you that in class, remember? I think he understood it. Time has to slow down the faster you go. It's just a result of the speed of light being fixed, no matter how you view it. And so that is one of the interesting things about time, the nature of time. That's when they realized, wow, if it's all relative, we thought time was something that progressed as a constant, and only our x, y, z coordinates in space are what changed. And now we know that's not true. So that's my definition.
Yeah, and we can actually see that, can't we? I mean,
in
when you've had rockets that were traveling fast enough and things like that.
Right, and it is an interesting thing. They actually have measured this with cosmic rays. Cosmic rays are particles that come in through the upper atmosphere. They hit our upper atmosphere. They're high-speed protons, things like that. Well, when they hit the upper atmosphere, they create a shower of other particles, such as muons, things like that. Muons should not reach the surface of the Earth because they don't last long enough. How do they make it to the surface of the Earth?
Time slows down for them.
They're moving close to the speed of light. And so what happens, time's going slow for them. So they can traverse that distance very quickly because their clocks are running slower. So we see this all around us, cosmic rays, things like that. By the way, how many had to use relativity to get here if you used your GPS? I say that literally. GPS uses special relativity and general relativity. Otherwise, you might find yourself over in Clues Hall waiting for this event to start. Okay, or something like that. So anyway, just another little tricks of what we find how time goes by for us. And so it is one of those interesting things with time. It's one of the things when our students in physics, sort of their eyes open up when they get into their first, what I call true physics class. Not the classical physics, which is the textbook has remained the same for the last 300 years, but what we call modern physics, which isn't so modern, it's now 120 years old almost. But we still refer to it as modern physics. That's where they start to touch on things like relativity. And they learn why time slows down. They learn why, for instance, what we know about the atom, things like that, okay? And so there's all these things in astrophysics we constantly have to deal with relativistic effects. So, and I'm sure all of you have seen things in movies. How many saw Interstellar? Okay, yeah. A lot of general relativity and special relativity in that, okay? I'm not going to hog this conversation, so I want to hear what you think the religious nature of time is.
Well, that's a good question. There's a sense in which, I mean, for those who, maybe it tells us something about the Bible. There have been people who've tried to make out that the Bible or other sacred texts have a handle on, science ahead of its time or things like that. We don't have either special relativity or general relativity in this. we get very much the worldview that ancient people had and they express their theology in that. And so one of the things that modern theologians wrestle with is how do you express a religious tradition that was formulated in the context of one worldview in another? And people keep adhering to religion, so it's clearly possible, but there's still a lot of debates about how to do it and how to do it well. But what about this idea that time is essentially a dimension like space, so time, past, present, future, if you could view it from outside, sort of all exists simultaneously or timelessly. Does that
So
make
you're bringing
sense?
up something that we refer to probably as a timeline, literally, which all of us use in modern day speak. Okay, we don't know it's actually something that's basically relativity. Yeah. Generally, when we talk about things, time goes forward. Okay, whereas in X, Y, and Z, we can go backwards, forwards, any way we want, move around. Okay, time we generally have to go forwards. That's one of the things we know. There is speculation, perhaps you could go backwards, particularly in Hollywood, in time that is, but it hasn't been proven. It's hypothetical. Whereas we know we can slow time down and things like that, we don't think we can go backwards in time. That is one of the things we probably cannot do. Sorry to disappoint everyone. So far, it doesn't mean we won't find that out in the future.
So we can still talk about time travel later.
Yes, we can. We can still talk about it later. Yeah, that is an interesting thing, and they have actually speculated about whether you can do it or not.
Yeah.
Okay.
It won't be plausible scientifically, but those who are fans of Doctor Who know that it's not plausible in all sorts of ways anyway. And so
Oh yeah, that
won't spoil it.
It makes for great science fiction, of course.
Yeah. One of the things I often think about, because as a physicist, you deal a lot with math and calculations, and that's the sort of native language of physics. And it's clear that the math works, but it's when you start trying to turn it into philosophy and ask, what are the implications of this for everyday life, that sometimes people do really weird things with your field, I'm guessing, sometimes.
Oh yeah, yeah.
And so this view of time as always existing, past, present, future, seems to have implications for things like free will, right? If time exists, there's a perspective from which past, present, future all exists, whether or not we can actually figure out how to get there from here, backwards and forwards, then it would seem like the passage of time is an illusion. And the decisions we're making in time about what we're going to do tomorrow, tomorrow is, from some perspective, already there. And so, what are the, do you
Well, it could be something like the butterfly effect. What I do determines what I do tomorrow. Okay, so today, it could be just a cascading effect. Also, our lives could just be pure chaos. I make this decision here, I go that route here. I become an astrophysicist. No, I take this route. I become a religion professor. Okay, so those things can't. If you can go back and think of one thing in your life, particularly us people who are not in college still, I think, okay, what if I would have done this one thing different that one day? How would have my life changed? Whether it's meeting a spouse or something like that. Okay, and those are sort of the things. Well, how did that all occur? It happened by a series of events that got you to that point. That suddenly you say you met your spouse, or you happen to meet some person that got you a job, or you were, say, at a meeting, or you had this great job interview or something like that on that day because you prepped for it instead of, acting like we were in college perhaps and waiting until the last minute. Okay, I see a lot of smiles around here. All right. So, but that's sort of my perception.
That's not a laughing matter.
Yeah. We laugh in private about this.
Yeah, well, there's no one religious view of time. There's certainly, just as there's no one religious view of, whether God is timeless and whether we have free will and all those things. And so, whatever curveballs physics throws at us, we'll find some way of, formulating theologies that take that into account as well as we can.
There is an interesting one which I've sort of barely made a reference to at the beginning about the light travel time to Jupiter. It's 25 light minutes away, which means light takes 25 light minutes to get here. Yeah, that's considered really, really nearby, by the way. Well, consider the following. The Andromeda Galaxy, which you can see in the fall here in Indianapolis. When we see that, the photons have traveled 2 million years to get here. So what we're seeing it as is 2 million years ago. When we look further out, we start to see things as they were billions of years ago. And we can see out to a point where we get to about 13.5 billion years or so, and we can't see beyond that, okay? Now, I'm not going to go into that one right now because it's coming up here, but let's consider that. That gives us one interesting thing that we can look back in time. So we're talking about time, looking back in time. Well, we can't move ourselves back in time personally. But think about it. If we see a galaxy 13 billion light years away, how are we seeing it? Not as it is now, but as it was 13 billion years ago. So literally, we can do, let's call it astrophysical paleontology type of stuff. Looking in the past. Not how the past was, how our galaxy was in the past, but how galaxies in general were in the past. And so we really have this interesting tool that time does, at least the speed of light is a constant, which allows us actually to go back in time to see how our universe was. And that is a very, very useful tool, which cosmologists absolutely love. Okay. By the way, cosmology is the study of the origin and fate of the universe. They ignore everything in between.
Yeah, and sometimes religion has focused on beginnings and endings as well, and so I think that'll be coming up probably in the next question. Thinking about the size of galaxies, I'm reminded of something that theologian Keith Ward pointed out, addressing the impact that changing cosmology, right, or changing view of the universe, or changing knowledge of the universe has to have on religion. If one takes, for instance, the story of Jesus' ascension to heaven, literally, right? We can work out, we know the size of the Milky Way galaxy. We know, unless Jesus has achieved warp speed, then he's still in the Milky Way galaxy. Right?
True.
And has a long way to go before reaching outside of the universe.
Unless Jesus created a wormhole somewhere.
Or something like that, right?
Yeah.
But,
Jesus could come out the very edge of the universe, visible universe, then. So.
But when you start...
I'm giving you true physics analogies here. Okay.
When you think about the implications of some of the things we know about the universe, and take things from the biblical worldview where heaven was, the heavens were up there but not so far away.
Right.
It really does, it makes us aware of just how much our understanding of the universe has changed.
Yeah, it's interesting in that fact. If you go back 100 years, which I think my student over there knows, we just started talking about this. 100 years ago, we thought our little corner of our Milky Way was all there was to the whole universe, 100 years ago. And we thought we were at the very center of the Milky Way. Not because we were egotistical, but that's what observations told us. And within 10 years, we realized the universe was billions of times larger than it was, okay? That there were other island universes we call galaxies today, and our galaxy was much, much larger than we thought. Part of that was the larger telescopes, but it shows you how quickly science can change. And that was one of the most remarkable times in astronomy when things change like that. Which also causes us to, book publishers love this, it means astronomy texts change every 2 years, and we have to get a new edition. Unlike that classical physics book that stays the same. You can use the one from 100
so you
years
have a
ago.
very good excuse that students have to get the latest edition of the text.
I hate to do that because they hate me for it. Well, I guess he threw up the next question here.
Okay, there we go.
Okay, all right. How do we understand the beginning and end of the cosmos and creation? Well, he put cosmos first, so let me go. Okay. I guess he's indicating I should go first. All right. So, was there a beginning to the universe? Do we know there was? Do we have proof of that? By the way, how long did the Bible say it took to create?
6 days if you follow the first account.
Okay,
let's talk about one day in which God created that.
Okay, okay. So let's just take everything. Okay, 6 days, and the seventh day was for rest. I'm just going to give you a little tidbit here. Anyone know about the days of the weeks or days of the week? How many days are there? Okay, very good. All right, you guys know your calendar very well. Okay, why are there 7 days of the week? Most people do not know this, but it's no. What's the first day of the week? What's it named after? Monday is Lundi, which is lunar day, moon day. What is Tuesday? Ever hear of Mardi Gras? Mars Day. Wednesday is Mercury Day. Thursday, we use the Scandinavian version, Thor, but it's actually Jupiter Day. Friday is Venus Day, and Saturday is guess what day? Those are all the objects that move through the cosmos relative to the stars. If they had discovered Uranus and Neptune, the ancients, we would have 9 days of the week and be very exhausted. Okay? So yes, there is a biblical thing that says there's 7 days, but they didn't put the week in that. The days of the week actually come from, the reason we have those 7 days of the week are because of the objects that move. So getting back to the cosmos, I just want to throw that in there.
Yeah,
but
let me throw in as well
okay.
that's where we get the idea of 7 heavens from, is the idea of the Earth at the center
right.
and the spherical heavens.
The objects that can move,
objects that move,
yeah.
so the visible
right.
object moving.
And then, because there were 7 objects that we knew that moved relative to the stars, 4,000 years ago or so. And that's why we have that days of the week. Now, as far as the creation, okay, prior to 1924, the going theory in astronomy, or hypothesis I should call it, was that we lived in a steady state universe. And it was a relatively boring universe, frankly. If steady state just meant the universe has been here, it's been here, it's going to be here forever. And it didn't have a beginning, it didn't have an end. And things which were literally steady state. Imagine just doing the same job on an assembly line day after day after day. That's what the universe was. 1929, Edwin Hubble, and actually I should go back even to the 19 teens, someone by name of Vesto Slipher, who was a PhD graduate of IU from Frankfurt, Indiana, was working at Lowell Observatory, hired by Percival Lowell, who he hired Klein Tombaugh, by the way, who discovered Pluto. You might say, where the heck is this going? Vesto Slipher noticed that all these things called spiral nebula, which we refer to as galaxies today, were moving away in general from our galaxy. Edwin Hubble got the distances and found that the universe was expanding. Well, if the universe is expanding, that indicated immediately to everyone it had a beginning. Because think of it. If you roll the film backwards, it means everything was much closer. And you can think of, okay, if I just keep going, I hit a point where everything's together. That is what we refer to as the Big Bang. And we know that occurred 13.82 billion years ago, I believe. We have it down to a 4th digit now. But before that, a curious thing, and we talk about this is something you don't even need to be a scientist. You just say, all right, and this is what we all ask in graduate school as undergraduates, whether you're in an introductory class or whether you're just drinking a beer at a bar, okay? What was there before the universe? What was there before the Big Bang? And astronomers say, well, we can get you back to 10 to the minus 45 seconds. That's really tiny, tiny time frame there. We hit what's called the Planck time. And then our physics breaks down and we don't know what happened, okay? So we only go back to 10 to the minus 45, and then I say throw it over to the philosophy department and let them speculate what happened, okay? I do say that. I say go over to philosophy and religion and ask them, and they might actually have a better answer than I can give you, because physics can't explain what happened before that. Now, the end is going a different direction. Yeah, I'll let you go. Yeah, go to the beginning.
I assume you're segueing to me there when you said, go over to the philosophy and religion.
Yeah, okay, so there. I shall. We'll let you go to the beginning, then we'll head to the end.
But what's interesting is...
By the way, we did not prep it all, okay? No. We did not prep it all.
We decided to have this conversation in public, and at some point we're going to invite them to maybe join in with us, but we're having too much fun to let you in just yet. But it's interesting. On the one hand, the idea that time had a beginning with creation is one that ancient philosophers and theologians explored. But theologians like Thomas Aquinas and others were very much dialoguing with philosophers, including some who thought the universe might have existed forever, and were very careful in articulating this idea that what they're talking about was the contingents of the universe, right? That it depends on God for its existence. And so even if there is a universe which is a steady state universe, that it's not self-explanatory, right? It kind of still cries out for, okay, well, where did this steady state universe come from? And there's a reason why we keep ending up with these discussions in the philosophy and religion fields, even if you posit a multiverse, right? So that, why do we have this one universe that has all these things that seem so perfectly tuned for life? Well, one possible answer is, well, there's an infinite number of universes, and in one universe there's going to be, it's going to be suitable for life, and beings are going to be there asking, how can this be so perfect, right? If you have infinity, that's the nature of it. But the interesting thing is that that doesn't solve the ultimate question of, where do things come from, or why are things the way they are, right? In fact, in some sense, if a universe that has life and people who can have these kinds of conversations in it, and people who can come and listen and look at the stars and wonder, a mechanism that produces infinite numbers of universes is every bit as puzzling, if not more so.
So God plays with chaos too, in other words, okay?
Yeah.
So let's try this universe. No, this one, okay?
Yeah.
That's
And
all.
I think the reason why, if you talk with biologists, biologists will be like, don't bring God into it, because biology, on one side it borders with chemistry, on the other side it borders with psychology and other things, and so it has its delineated field, and it, when it runs out of answers, it knows where to pass the baton to. Whereas physics really does take us as far as science can go, and people like me speculate about
well,
what's
that's why we need.
But
yeah. Well, technically, I have my degree is in philosophy.
Yeah.
Well, I have a PhD,
Yeah. There you go.
which is Doctor of Law, which I know very little about. I know a bit about religion. I was an altar boy for 4 years. I still have memories of that.
So we start at the beginning, both of us, and then we fast forward past all the stuff that doesn't interest either of us that happens in between, right? And then we get to the end.
Even though my research is
Yeah.
Okay, but anyway.
And I'm kidding. I think a lot of interesting stuff happens in between, including conversations about the beginning and the end. But where does physics take us for the end?
Well, up until about 15 years ago, we didn't quite know what the end was, okay? The one that most people were hoping for, including the Vatican, okay? And the Vatican, just to let you know, unlike 400 years ago in the days of Galileo, they actually have their set of astronomers. They have the Vatican Observatory, which is somewhere in the American Southwest here. And they are actually quite, literally, very progressive as far as astronomy goes. I actually meet them at international conferences. No, they don't have their collars on, the Jesuits and everything. They just look like normal, scientists like me, which that's, hopefully they don't look at me, that'd be bad for them. But anyway, the interesting thing is, and the question was, how dense was the universe? That was a very key question since Hubble discovered that it was expanding, which meant it had a beginning. If it's expanding like a big explosion, and no, it's not just happening here, it's an explosion happening everywhere, which we're still in. The galaxies are flying apart from one another. If it was dense, it means there's enough gravity between the galaxies that, just like I throw my keys upward, what will happen to them? They come back, right? Because there's enough gravity there. Well, what if I throw them harder? What happens? They go faster, right? And go higher in the sky. What if I throw them at 11 kilometers per second and remove the atmosphere, this ceiling here, they would escape from the Earth. In other words, they would continue to go forever. Now, that would mean there's not enough gravity. That gets to density. There's not enough density in that universe, there's not enough mass, which creates gravity. So the key thing they were trying to discover in the 1990s with all the new technology was, how dense is the universe? How is that set of keys decelerating? Is it decelerating enough that it's going to fall back in my hand? In the context of the universe, we have the Big Bang, which expands outward, comes to a stop, and does what? Comes back together again in what they refer to as the Big Crunch, okay? Or the Gnib, whatever, if you spell it backwards, okay? Which Bob Kirshner at Harvard always spelled it. But anyway, so they were trying to measure this deceleration parameter. Does it slow down, or is there enough deceleration there? So, 1998, I'm at the American Astronomical Society, and rumors were out about this, and the rumors said that they found something really weird with how the universe is accelerating or decelerating, particularly about 5 billion light years out there. So I went to hear the talk by Bob Kirshner, and my jaw dropped. Okay, here's what they found. You throw your keys up, okay, galaxies in this case. They started to decelerate in the first 5 to 10 billion, or 5 to 9 billion years of the universe. And then imagine your keys magically saying, I'm out of here, and just like that. The universe over the last 5 billion years, in other words, in our neighborhood now, is accelerating, not decelerating, which it should be. And we don't know exactly what's causing that. And what astronomers refer to it is the quiescent vacuum energy, means something out of nothing, okay, which we would all like to do, or dark energy, okay? we come up with these great terms in astronomy that are easy to understand. Dark energy, dark matter, red giant, black hole, okay? Dark energy means, because it's dark, yes, it doesn't give off light. It's some sort of energy which causes this pressure that pushes the universe apart. The more vacuum there is, guess what? The more of it there is. So if it starts to accelerate apart, what happens? You open up more vacuum, more pressure, and it's a sort of snowball effect. And so the question is now, is it going to be a big rip, where just things rip apart or just fly apart forever? And we really don't know what the end state is, other than it's going to expand forever now. There is no big crunch anymore. So the end is going to be basically the universe becoming a cold, dark place eventually. But we're talking trillions of years from now. So I'll let you have it now. Give me the religious point of view here. You can talk Revelations or whatever.
Well, we can talk about the Book of Revelation, which has some stars falling to Earth and things like that, which again are an older cosmological.
That would be the big crunch. I think.
That would be the big crunch.
Yeah, big crunch. Stars coming back at us.
And it's interesting that when people talk about taking Revelation literally, they never mean that. I've heard people who say they're taking Revelation literally who thought those were going to be like nuclear missiles or something like that, but that's not a literal reading. You'll see, it doesn't say nuclear missiles. It's stars. A star falling to Earth. A star is actually much bigger than the Earth.
I think it'd be the other way around.
You try and take some of those things literally. It reflects an older view of the universe. But people still wonder, much more about, I think, individual potential to, survive beyond death. Very few people, I think, even religious people, are very concerned with what's going to happen 13 billion years from now. And that's actually worth noting, theologically speaking, because it reminds us that actually when we formulate theology, usually we do so in a very, what's called an anthropocentric kind of way, right? It's focused on us. Are we going to survive? What's our future? What's our destiny? But the truth is that when you throw evolution into the mix, I mean, if we survive as a species that far into the future, we're not going to be anything like what we are now.
Yeah, what is it? Something like 99.99% of all species have gone extinct. Yeah. Okay.
We could buck the trend, but our descendants, as a result of evolution, will look very different.
Well, by the way, we're going to have to get off the planet in 2 billion years anyway.
Yeah.
So no matter what happens, because we're going to undergo a runaway greenhouse effect like Venus, because the sun is ever so slightly increasing its brightness. And then in 5 billion years, we're going to get cooked. It's going to be fried. We're going to be toast, because the sun becomes a red giant. So you can see, no matter what happens to the universe, we have some very short-term worries. Okay, and besides, well, there's a lot more here on Earth besides 2 billion years out. Don't even worry about right now. Worry about the next 50 years. And
there's some religious views of the future that involve a place that's very hot, but I don't think it's talking about the same thing.
Well, it's those who are left behind, and the rest of them go off in spaceships.
There you go. Well, it's interesting. I mean, one reason why I think it's fascinating to explore science fiction, maybe this kind of straddles this question and the next question, is that there's a sense in which a lot of science fiction is really a modern, sometimes secular, but sometimes spiritual reworking of these big, philosophical, ethical, and other kinds of questions, right? So what does the future hold for us, right? And it's less, can we, is there a chance that we will spiritually transcend our individual deaths, but can you download your consciousness into a robot and live forever that way, and those kinds of things. But there's a sense in which you look at, there are UFO-focused religions. Mm-hmm. And the reason for that is that religion, for a very long time, was talking about, people going up there, being from up there, coming down. So much so that, I oftentimes, when I'm teaching my class on religion and science fiction, I'll start things off by talking about a scenario that I think everybody's familiar with, where beings from up there come down here and take one of the people from Earth and take them on a celestial journey where they learn that there's been interbreeding going on between these beings from up there and humans, that these beings are responsible for giving us our greatest technology, and that disaster is going to come on the planet because of all these things that are going on. And ask them, what story is this? And oftentimes they'll say the X-Files or the classic.
I was thinking the X-Files.
The classic abduction scenario. But it's also, and I worded it very carefully so this works, but it's not hard. It's also the story of the Book of Enoch, which is this ancient Jewish apocalyptic work that explores the story of the character of Enoch that's mentioned very fleetingly in the book of Genesis. Religion has been about what's up there and how do we relate to it? What's our place in the universe?
It is interesting, which doesn't have to do with time, but Church of Latter-day Saints, alien civilizations. Okay.
They found a way to work that in.
Yeah,
It's not surprising that there have been some great works of Latter-day Saints science fiction, right? Battlestar Galactica is the one that's probably most people familiar with.
And that is one thing, and we are now starting to find not Earth-like planet, but Earth-sized planets in the last 5 years or so around other stars. By the way, 20 years ago we knew of, or 21 years ago, we knew of 0 stars circling other planets. Now we're approaching 5,000 candidate planets. And it's going to just keep growing exponentially as we have equipment. So it just shows you how technology is helping us. So we'll find that planet to get off hell here in 2 billion years or so, and whatever.
Yeah, and science fiction is us thinking.
As a science making sure. Okay.
Let's do it. Yeah.
Okay.
The next question is about implication for our own place in the universe and our meaning making as humanity. To further understand, manipulate time. So there's the time travel.
Yeah.
We don't know if we're ever going to get there scientifically, but I think there are lots of interesting religious questions that one can explore using time travel. Right?
Mm-hmm.
In fact, one of the most interesting conversations I ever had with someone on my blog, so interesting that I've incorporated this thought experiment into classes that I teach, but was having a conversation with someone who self-identified as an atheist, and basically said, you can have a TARDIS, right? You can have a time and space machine. You can go anywhere in the universe, any period of time. What would it take to make you lose your faith? Was the question he asked. And I think that's a brilliant thought experiment because it really gets at the heart of what you believe, why you believe it. Are you open to evidence challenging your beliefs? Right? There are a lot of one approach to religion is to say that you take things on faith, which oftentimes simply means I'm going to believe whatever my parents told me, regardless of what evidence this professor presents in this class or something like that. But there has been a very strong theological case made that that's not really the best way to view faith or to approach religion. That in fact that leads to dogmatism and to idolatry and other things. And that in fact if faith is really about being concerned with what's ultimately important and what the big questions and things like that, being concerned with things like truth so much that we're dedicated to the quest for truth, then questioning your own beliefs can actually be an expression of faith. Right? If truth is what really matters to you. And so there's an interesting thought experiment. I won't take up time, talking about my own kind of exploration.
I'm going to go down a slightly different road than you did here, since you're religion, I'm science. Okay.
Yeah.
I was thinking of there's a great book out there called The Ethics of Star Trek. I don't know if and it's the physics of Star Trek too, and there's one I think called The Ethics of Star Trek, the physics behind it and everything. Because it really isn't, those of you who saw the original with Captain Kirk and Spock and stuff, they have all these, sort of humanity issues that we're dealing with in the late 1960s, but when you think about the physics, what they do, there are some things like, is that ethical? And I'll give you an example which doesn't have to do with this. A transporter. Well, how do you transport someone from point A to point B? Do you map their body, then recreate it up there and kill the one down here? Or, how do you do it then? It's really hard, okay? Or do you send it up there to do this, and then they actually went through the transporter issues and stuff like this. Well, it might not be ethical. Another one is traveling. Let's say we do go out into space, we start traveling near the speed of light. Or you do what, say, in Interstellar, which had to do with getting into a very, very deep gravitational well, which slows down time for you. Is it ethical to send people out there that come back and, their children are dead, or things like that? You have all these issues, okay? Just like even ethically sending someone to Mars, is it ethical to send someone to Mars knowing that, things are dangerous? So you do have a lot of things coming into play there, particularly as you start dealing with getting off the Earth's surface, all right? And by the way, just to let you know, the space shuttle, when it's in orbit, yes, it is going so much faster than we are, 7 kilometers per second. So you think, oh wow, their clock slows down. But we have an advantage that we're deeper into the Earth's gravitational well down here. So our clock actually slows down. So it's basically a wash when they come back, okay? We're back to square one again. But that is probably the biggest thing. Can we manipulate time as far as humanity goes? Well, you get into those paradoxes of traveling, for instance, in Star Trek, they sort of ignored this. If they're traveling at warp speed of sorts, time should slow down dramatically with them. And so when they come back to Earth, I mean, how do you keep a clock with everyone going at different speeds, in the galaxy? Well, my clock says this, okay, there's some, standard, like a world clock service or universal clock service you go to. So there are interesting aspects to this because you do get into problems of relativity. It's like, well, hold it. Well, I'll meet you at the center of the galaxy at 5 o'clock, okay? It depends, well, keep in mind, yeah, it might say 5 o'clock on your clock when you get there, but the other person, you might be 5 hours late perhaps. And so you have all these issues you have to deal with. So you're going to have, instead of us thinking in 3 dimensions in the future, once we get to that, hopefully to that time when we're traveling through space, we're going to have to think in all 4 dimensions, that time dimension. It's like, okay, set my clock so I get there, I'm traveling at this speed, so I'll get there at this time. Not just like, okay, I'm driving 100 miles an hour, and it's 200 miles away, it's going to take me 2 hours to get there, okay? Oh, and my clock's really going to slow down on the way, so I got to take that into account, so I'll arrive early to my appointment. So it really becomes an issue then, okay? So yes, we hopefully will be able to manipulate time in the future if we get to these speeds.
So we'll need those starbeams to, that's probably the system.
Yeah, and I'm sure they have some scientific way in Star Trek is how they keep everything calibrated and everyone on the same time system, okay?
Yeah.
That's the beauty of science fiction. They can roll over the facts, okay?
Yeah, but I think that even if the science doesn't pan out, the thought experiments can be really useful, and they can be useful philosophically, and they can be useful theologically and religiously, right? As people think about, if you have a belief in an afterlife or something like that, so is that you being recreated? So you have the same transporter problem, right? And is that worth hoping for?
Just take a body scan right now, and then 100 years ago, just recreate yourself.
Is it enough if you're
and put that USB or that
Yeah.
flash drive back in your head?
You think about the possibility of the same entity existing. I mean, you need essentially what becomes an infinite memory expansion for all the memories. Otherwise, you don't remember the past. And so, there's no vision of the future, whether it's through creating androids that supplement us, or we can download ourselves into, and then you again have the copying issue. I think they found a workaround. We can talk about that later.
Okay.
But we have the same kind of issues come up in science fiction and in talking about religious viewpoints that people have. And so I think science fiction oftentimes gives people some useful thought experiments to work with to think about those things.
Yeah, and one thing I remember, one of my first years here teaching at Butler, I did have a student come up to me. He is from the Caribbean, and he, after about 2, 3, 4 weeks in the class, said, this class is shaking my faith. I said, well, I'm not intending to shake your faith. Okay, you can keep your faith and still be, and understand science. And that was a key. He'd never been presented with certain ideas, though, that sort of like make you think. And it is interesting when I never really thought about religion and science in any controversy between them, because I went to Catholic schools for a while. They teach evolution one day and you have religion class the next. There's no question about it. Things like, oh, the universe is this old, and then they go at the Bible, it was created in 7 days. It's just like, well, okay, whatever. I'll just, okay, which one? I'll throw a dart, pick one here, and okay.
Yeah.
So.
It's so interesting that students would say that a physics class challenges their faith, because if they take a religion class, it challenges their faith too. So.
Well, I mean, one of the things that is, you start thinking of, and no scientist ever really says that, I don't anyway. But one of the things I say is you can't prove or not disprove there is a God. Science cannot do that, okay? All science does is try to explain what we see around us and to explain it. That's all it's trying to do. It's not trying to say there is a God or not a God, and you just can't prove it. Because you can't, it's sort of like faith, okay? Faith is not science, okay? It's like, well, I have faith in this equation, okay? I have faith that Newton's law is going to get me to Jupiter and it's going to get me home tonight, okay? I sort of do have some faith in that car I'm getting in, so. But, it's a weird thing how you separate the two. And I think physics, we really don't I mean, frankly, I don't care that much. So I mean, by that I mean the separation between, okay, you got to keep religion here and physics here. Well, physics is physics. I mean, I just follow the route. Okay, the equations lead me here, the data leads me here, and I just okay. So it is interesting. I mean, I will say this. One of the things I remember when I was a postdoc, just out of graduate school, I was down in La Silla, which is one of the European Southern Observatory, one of the darkest skies I've ever been in. You can't see your hand in front of you. It's so dark. The only way I could see my hand is hold it up in the sky and block out stars. And then it was, just, oh, okay, there's a black hand up there. Okay, nothing else is up there. And I remember sort of just, okay, I'm going to just lay back and look up, okay? And I laid back and looked up, and all I could see was the sky, the Milky Way, thousands of stars. And it was the first time I felt I was in space. And it felt like, and then I realized I'm on this ball that's hurtling through space. And it sort of gave you this feel that, oh, I'm part of this space. It's not there. I am in all this. And it sort of gave me a realization that, you start thinking, wow, that's a lot of real estate out there. It sort of hit me when I was, of course, 30 years older. So, but it really is an interesting feel when you see that. I mean, it just sort of opens your eyes and makes you, it goes back to, well, philosophy, okay? I mean, it's like, well, I know how these stars, why they're all their different colors and all this, but where did it all come from? How did we get, what happened? Going back to one of our previous questions, what was there before this? How did it get to here? How can we have hydrogen and we have the periodic table? What caused, for instance, stars to go from helium and skip over beryllium and go right to carbon? Because without that, we wouldn't be here discussing that. Stars do that. Most carbon in your body is from red giant stars. And there's some interesting little aspects that we wouldn't be here if you changed one little thing here or there. I'm not saying that proves there is a God. It doesn't. It just says, like he said, if there are other universes, ours is just the one that happens to be right, that we exist in it. And the other ones don't have any life at all. So it brings up these questions. And by the way, multiverses is a very hypothetical thing right now, okay? Which people suggest. We know there's one universe. That's the one we live in. And we know that there is life in it. We know there's one planet that has life on. And that's the one thing that makes this Earth special. Until we find life somewhere else,
We can't talk about the odds.
Yeah.
One out of one Earth-like planet that we've surveyed has life.
Right, so exactly.
But it's interesting. I often, when I get to the Psalms in my course on the Bible, we get to Psalm 8, which seems to have been written by someone who was looking up at the night sky and thinking of the universe as creation. And so, but is still thinking in the same way that anyone who looks up at the night sky does. What's our place in the universe, and how do we make sense of it? So people have been asking those questions for a very long time.
Right. Yeah, and it is one of those things that, it in a way it got me into science. Asking questions. And as I tell students, I said, and all of you remember this, the people who are college students here. One thing I said, I never want you to lose that aspect of life you had when you were 4 years old, which annoyed your brothers and sisters and your parents when you said, why? Why? And you say, and you answer, and they say, how come? Why? And they finally say, oh, shut up, kid. Now, hopefully your parents did not do that. But I was one of those annoying little kids. I was like, why? Why? And that is one of the things that makes a good scientist. And hopefully most scientists never lose that. You're always asking why or how something got to the way it is. And it's the same question like, well, how did the universe get here? It doesn't matter actually whether you're a scientist. You're asking questions. And that's a key thing in understanding, asking those questions. Because once you lose that, and you lose your intellectual curiosity then, if you stop asking the question, why? So that's basically what this is partially about, is what and what. So.
Yeah. And I think there's, I just wanted to say that, I think the same can be said, from the perspective of religion and theology, that, a lot of people think, well, science gives you some answers, but then you turn to religion and it gives you, the really important answers. But there's a sense of, religion is, like science, a human enterprise.
Yeah.
And
physics is a human enterprise, keep in mind. It is.
So that's why we can have these conversations, because it's not like one of us has the answers and the others. Or,
Yeah.
But, we're human beings thinking about these things together and trying to make sense of it all.
Yeah.
And that, I think, is a good place to...
Right.
That's a great segue to the point of questions. I wanted to take a few minutes if there's any questions for either or both of our speakers. I can kind of point and field. So we've got one right here. Can you speak up?
I'm interested in this concept of time. Time passes and such, and we figure it in terms of our lifetime. You're young, you're old, if it's 5 minutes, 20 minutes, you're 15 minutes late. We think of then, our society says, there is a God who is eternal. How could God understand or comprehend our short lifetime when he is eternal? So far we got 14 billion years. So it really bothers me. I don't know if you have any thoughts on that.
You know, that bothers me too. When I think about it. So.
Well, I think it's good that it bothers you because you're thinking about those
Yeah.
things. I think there are lots of people for whom the thought never occurs to them, and that's, I think, much worse than it bothering you. I think it should, it's the sort of thing that people should think about. There are basically two different views that people have had about what it means to speak of God as eternal. One is the idea that God is outside of time and so is timeless, in which case, that's an idea of God as
it
unchanging, and so God doesn't understand what doesn't see it from could never see it from the perspective of what it's like to be inside of time. The other view of eternity is of a God who is experiences succession as we do, but without beginning, without end. So endless duration rather than being outside of time per se.
And it could be there are other dimensions. And if there are other dimensions, who knows how time flows in these other dimensions? I mean, once again, speculation, okay? We know of 4, X, Y, Z in time, okay? Whether there's others, that's speculation at this point.
Albert Einstein said, God doesn't play dice with the universe. Please explain this in one sentence.
Certainly. He was not referring to time, he was referring to the field of quantum mechanics. And quantum mechanics is all about probability. For instance, if you're looking at an electron circling a proton, the classical view by Bohr was, oh, there it is, right there. No, it's somewhere there. Okay, that's all it said. And we know approximately where it should be. And that comes out of when you get down to the or actually nanoscopic level. And Einstein, he was, remember, on the large scale side of things. That is the universe, relativity, things like that. Quantum mechanics dealt with the small. And so Einstein was not an expert at that, just to let you know. He was more on the large scale relativity. And so that's where he said God doesn't play dice. He was wrong, okay, on that one. That is one thing he was wrong on, okay?
Is that a theological statement?
No, he was not God. I'm not saying God was wrong. I'm saying Einstein was wrong. Okay?
But he was wrong. Was he wrong about whether God plays?
Well, he's wrong that the universe does on the smallest scale. Now, we live on the large scale, so we don't see this probability that goes on the very small scale. All right, but we can see it as far as when we design electronics. We have to worry about that issue of quantum mechanics and that rolling the dice, whether electrons find themselves on another circuit, for instance. We have to build in redundancies into all our circuits.
Yeah.
So I hope that answers some of it there.
Yeah. The older view that the sort of Newtonian view of the universe was that it's all billiard balls, and if you understand the causes, then you can understand it all. There's no randomness about it. I think the one sentence answer to the question is, I'm trying to remember if it was Erwin Schrödinger or if it was somebody else, but somebody responded to Einstein and said, stop telling God what to do. And, it was Niels Bohr? Was it?
Okay.
Yeah, there's somebody over here.
It seems to me that one of the main contentions between modern science and religion is due to a misunderstanding of relativity. I mean, some theologians said Einstein's theories meant that everything is relative, when in fact it didn't mean that at all. I was wondering if you could comment on that.
Yeah, well, I think, I've done more, I think probably spent more time dealing with some of the ways people have taken things from biology and done really problematic things with them. But we have a tendency as a culture to take the kind of work that scientists do, take an idea or even take a word and misuse it in some kind of broader cultural fashion. So relativism, as the supposed implication of relativity, is, I think, a really good example of that. But I mean, there's a sense in which the fact that time is relative, depending on your viewpoint and the speed that you're moving and things like that, doesn't mean, as students say over and over again in assignments that I read, everyone's view is different. The very fact that so many students over and over again say this exact same thing, I think, is disproof of the viewpoint, right? Students seem to agree on this, right? But the universe is complicated. Life is complicated. There are things we agree about and things that we disagree about. There are ways in which we're all unique. There are ways in which we're all basically the same, and there's a whole spectrum in between. And both sciences and the humanities are attempts to try and get a handle on that, and sometimes we boil things down to an equation or things like that, but that's just to get a handle on the complexity of the way things really are.
I agree with everything you said there. So.
Sometimes science and religion agree.
Yeah.
Is there, have we proved any aspect of randomness in the universe? And if we can prove that there's randomness in some aspect of human behavior, does that provide a good argument for goodwill?
Or for free will?
Or for free will?
Is that yours or mine?
Well, I think it's both of ours, but randomness, yes, it does exist. But it exists on the smallest levels, okay? In fact, you get taught about randomness in a class called statistical physics, which all undergraduates have to take, which basically deals with the fact that individual atoms all have, don't take me literally, a mind of their own. They're going this way, that way, but we can describe the bulk nature of a gas, which all those of you who had high school chemistry know, and it has Boyle's law, for instance. Okay, you can derive that law based from what we know about the randomness of particles. So there's randomness. Once again, this gets to God playing dice. There is that randomness at the small level, but it's almost like going to Las Vegas if you know how to play the tables and stuff. You know what the probabilities are. You can determine. That's what we have done. We basically, Las Vegas doesn't want us there anymore. Not physicists in general, because we figured out how all that randomness comes together and how it works.
Yeah, and I think randomness and indeterminacy, they seem, on one level, they seem like they might make room for free will. On the other hand, if we could trace down the processes so that the choice that we make to go to this university rather than that university, or to follow this religion rather than that religion, or this career path rather than that career path, is due to something that's random, I don't think that would be reassuring to us in terms of our sense of will. Will is the sense that we can actually decide and choose, and it's more to do with self-determination than randomness in a sense. And really, I think the reason why we don't have a good handle on that, I think part of it is, what's called the hard problem in neuroscience. The fact that we don't really understand consciousness because it's us, and we can't really study. I mean, we can't observe it. We can't. The words that I'm saying now, the words that you're thinking now, they come into our head somewhat fully formed. We don't piece them together sound by sound, letter by letter. And what you can think about your thinking. You can think about the fact that you're thinking about the fact that you're thinking, and you can. But however much you try to add another layer on, we can't really trace where all that emerges from. It's like the code that's running. When you're using a computer, it's behind the scenes, and you don't really see it. You just have the we have a really cool user interface that works well for us, but we don't really know how it works behind the scenes. And so there's a sense in which, that's one that philosophy, physics, neuroscience, all wrestle with, and people have some strongly held views on it, but we can't really seem to get to the root of it. And there are probably some inherent problems with us, that might keep us from ever doing so.
Yeah.
One more question? Yeah.
Yeah, I noticed on the opening slide, the torus, it was like shifting and moving. That is a torus, right?
Yeah.
Is that how it's described? Now, I mean, so I guess this has been speculated or may even be proved as the shape of the universe. Am I correct? Or
Close.
could
close.
you explain that more?
Yeah.
In short,
Here's a way. I think what you're getting at is the following. Remember I told you whether it was a big crunch or just
yes, that's
a
exactly
big
what
chill of sorts where it expands forever. What he's referring to, the way to think of the big crunch is we call that a closed universe. This is a closed surface. It closes in on itself, as you can see. And you might say, well, hold it. If the universe is infinite, how can it close in on itself like that? Well, think of an ant on a very, very large globe. They see it as pretty much flat, right? Can they travel forever on that globe? They certainly can, in a straight line, and never come to an end. That's what we think. That's what we refer to as a closed universe. But it gets harder when you think in 3 dimensions. Okay,
Yes.
so you try to visualize that as a closed surface. It wouldn't be a donut shape, though, the universe. Okay, if it were, this would be a big crunch universe, but not donut. It'd be more what we call sort of a spherical in 2 dimensions. Okay.
Mm-hmm.
Yeah, and I just have to say that if physics had shown that the universe was a giant donut, I mean, religion could have done all kinds of great things with that. But